Can planets that become uninhabitable later become habitable again? After being stripped to its core by the intense heat of its star, an exoplanet 41 light-years distant is showing signs of gaining a second atmosphere, through volcanic activity. Called GJ1132b, the planet was studied by NASA's Hubble Space Telescope for a paper to be published soon in the Astronomical Journal. Said to have tantalizing parallels to Earth. Here's everything you need to know about GJ1132b, a once-watery planet with a similar density, size, and age to Earth. GJ1132b is a 4.5 billion years old exoplanet that orbits a red dwarf star 41 light-years from the Solar System. It completes one orbit of its star every 1.5 days from very close to the star. As well as once having a hydrogen-dominated atmosphere, the team's work also suggests that GJ1132b and Earth now have similar atmospheric pressure at the surface. Its theorized loss one atmosphere and gaining of a new one may have huge consequences in the search for an Earth 2.0, and possible life outside the Solar System. From its primordial beginnings as a bigger-than-Earth gaseous, sub-Neptune world with a thick atmosphere of hydrogen and helium, GJ1132b would appear to have been stripped of it by intense radiation from its host star to become a bare core about the same size and density as Earth. Now it's regenerating a second atmosphere, and that's a huge surprise to astronomers. We first thought that these highly radiated planets would be pretty boring because we believed that they lost their atmospheres, said team member Raissa Estrela at the Jet Propulsion Laboratory, JPL, at the California Institute of Technology in Pasadena, California, USA. But we looked at existing observations of this planet with Hubble and realized that there is an atmosphere there. Hubble has just uncovered a secondary atmosphere around GJ1132b. Rich in hydrogen, hydrogen cyanide, methane and ammonia, and with a smog-like haze of hydrocarbons, that new atmosphere around GJ1132b has puzzling origins. The paper theorizes that some of the original atmosphere's hydrogen may have been absorbed into the planet's molten magma mantle. Now it's being blasted back out by volcanoes to form a new atmosphere. The discovery is based upon a combination of observations and inference through computer modeling. This second atmosphere comes from the surface and interior of the planet, and so it is a window onto the geology of another world, said team member Paul Rimmer of the University of Cambridge in the UK. A lot more work needs to be done to properly look through it, but the discovery of this window is of great importance. How many terrestrial planets don't begin as terrestrials? Some may start as sub-Neptunes, and they become terrestrials through a mechanism that photo-evaporates the primordial atmosphere. This process works early in a planet's life, when the star is hotter, said lead author Mark Swain of JPL.